Okay, number 1. Suppose Lonzo places $4,500 in an account that pays 8% interest compounded each year. Assume that no withdrawals are made from the account. So let's go ahead and find the amount in the account after 1 year. So we're going to be using this equation. The amount of money we have is equal to the principal, the amount we put in the beginning, times 1 plus our rate to the time. And if they were going to pay this out in payments more often than once a year, we would need to put the divided by n, and I think that'll come up in a different problem, so we'll work it when we get to it. Okay, so the amount we're going to have in 1 year is equal to $4,500 times 1 plus the rate, and 8% is 0.08. So 1 plus the rate is 1.08. To the time is 1. So our exponent is 1. That makes the math kind of easy. Grab a calculator, and we will do 4,500 times 1.08, and we will have $4,860 at the end of 1 year. All right. The next question says, find the amount after 2 years. So let's just go up here and change this to a 2. And so the amount after 2 years is going to be, I have a real simple calculator here right now, so I'm going to do 1. Actually, I don't even know if it does exponents. That's very bad. Let's try this. Alexa, what is 1.08 to the second power?
1.08 to the power of 2 is 1.1664.
1.1664. Alexa, what is 1.1664 times 4,500?
1.1664 times 4,500 is 5,248.8.
All right. So if Alexa's right, those are our numbers that we could fill in there. Not sure I will remember them when I delete my screenshot, so I probably won't. Go ahead and enter them. All right, second problem says, a certain forest covers an area of 3,100 square kilometers. Suppose that each year this area decreases by 6.75%. What will the area be after 14 years? All right, so let's work with a decrease equation. It's very similar to the one we just used. Sorry. I'm not grabbing the corner for a screenshot, just right here. Okay, so we have the amount equal to, the initial amount was 3,100. That's our P, times 1 minus, in this case, we're going to subtract 6.75%. That's 0.0675. Okay, remember, when we're doing percents, we always move the decimal 2 spaces. And then the exponent in this case is going to be 14, because we have 14 years. All right, let me see if I get Alexa's help again. Alexa, what is 1 minus 0.0675 to the 14th power?
1 minus 0.0675 to the power of 14 is 1.
Oh, that didn't work at all, did it? Alexa, what is 1 minus 0.0675?
1 minus 0.0675 is 0.9325.
Alexa, what is 0.9225 to the 14th power?
0.9225 to the power of 14 is approximately 0.3232.
I'm not sure I heard her right. Alexa, what is 3,100 times 0.2222?
3,100 times 0.2222 is 688.82.
Okay, I think there was a decimal here. Said round to the nearest square kilometer. Not totally sure that the math went right with Alexa there, but that seems reasonable that after 14 years and we're decreasing, we're down to 688 square kilometers. That could very well be true. But this is definitely the math you want to do, and hopefully you have a better calculator handy than I do. Third problem. A study is done on the population of a certain fish species in a lake. Suppose the population size, P of t, that's like y, after t years is given by the following exponential function. We're going to find the initial population size. That's pretty cool because if you just know that these formulas come in this same amount, sorry, fevers will do this to you. These formulas come in this format, we know that the p in our equation would be the number 440 here. So this would be 440 is the initial amount. Does the function represent growth or decay? Well, here's my growth factor. My growth factor is 0.68, and we know if the growth factor is less than 1, we are going to decay. So if it was 1.68, we'd be growing, but it is not. It says, by what percent does the population change size each year? 68%. 0.68 is the same thing as 68%. So that should be correct there. Okay, number 4. To begin a bacteria study, a petri dish had 2,700 bacteria cells. Each hour since, the number of cells has increased by 7.9%. Let t be the number of hours since the start of the study, and y be the number of bacteria cells. Write an exponential function showing the relationship between y and t. So we know that we're going to have an initial amount. We're going to have, A is our final amount. We're going to call that y because they're asking us to call it y. We're going to have p, a starting amount. We're going to have a growth factor of 7.9. So that's 1 plus 0.079. And then we're going to have an exponent here to the t. Our initial amount was 2,700. I could have written that in the first time around. 0.079 to the t. They don't actually ask us to calculate anything. They just want us to have a handy-dandy formula that we could use to calculate how many bacteria are in our petri dish at any given time. And time in this case is hours. Okay, number 5. Pablo deposited 4,000 into an account. Sorry. Come on, I just need my screenshot. Okay. With 2.4% interest compounded semi-annually means twice a year. Assuming that no withdrawals are made, how much will you have in 10 years? So the formula for this is A equals P times 1 plus the rate divided by the number of payments to the time times the number of payments. So let's go ahead and fill these things in. We want to know an amount of money. We're starting with $4,000. We're going to do 1 plus the rate is 0.024 divided by twice a year to the time is 10 years times 2 payments every year. So we're going to be doing that math in the calculator. Be careful. Some calculators are pretty good at doing these things just the way they're entered, but to be safe, you can do this, get it done, enter, and then do it to this exponent, which is going to be 20. This to the 20, hit enter, and then times that by 4,000, and you'll get the final answer. I don't think I'm going to even try. I don't know. Maybe I can try. 0.024 divided by 2 is 0.12. Alexa, what is 1.012 to the 20th.
1.012 to the power of 20 is approximately 1.2694.
Okay, and you wouldn't want to round this before you finish your numbers. But just use that number right in your calculator. Excuse me. There's a calculator here. Alexa, what is 4,000 times 1.2694?
I didn't catch that.
Whoops.
Could you repeat your calculation?
4,000 times 1.2694.
4,000 times 1.2694 is 5,077.6.
Okay, so that's what I get if I did the math right using Alexa. Makes sense after 10 years that I am earning just a little bit of interest. That's not very big. And I definitely increased my value. I'm up to $5,077.60 instead of $4,000. So give those a try. Let me know if you still have questions. And I'll be seeing you.